what is happening. This video is another collaboration video with Algebra. He is doing math videos every single day. I think this is an old screen cap. I think he's about 350 something. He's closing in on a year. So check him out. How this usually works is I'm going to solve this problem and Algebra will solve them. And we will splice those together and see what we come up with. We don't meet prior to this or go over solutions or techniques. We just sort of do it and edit together. So you'll see his solution and my solution. There's two approaches to this. I think the one that is more tedious and the one that is less tedious. So let's go through the tedious solution. So our goal here is to find a closed form for g of n of x. So in other words, g raised to the nth power of x, where g of x is 1 over 1 minus x, and x is non-zero. This is the Mobius transformation. Dot, dot. Might know Mobius from the Mobius strip, but I've done a video on the group structure of Mobius transformations. There we go. The link will be in the description. If you want to see how these things sort of stack up as a group structure, we'll get into that. So first, let's look at what g of n is. What does that mean? Well, it's a composition, right? It's g composed with g n times. So in other words, if I have g to the third of x, notationally, this means g composed with g of x, which is iterative, where I'm plugging the value of g inside the value of g inside the value of g. So what we want to do is find a form that we can describe the n compositions of g in such a way that we don't need to compose 100, or in this case, 1,972 functions inside of each other. We want to be able to do this rather simply. So let's look at, we know g of 1, we're given g of 1, it's 1 over 1 minus x, where x is not 1. So one good way to start, I suppose, is to look at what's g squared of x. Again, this is g composed with g, which is essentially taking g and putting g inside of itself, which looks like this. All right, so if we clean that up, we get 1 over, now I need a common denominator to add those. So I need to multiply the left term by 1 minus x over 1 minus x, and that's subtracting of 1 minus x. So what we get is 1 minus x minus 1 over 1 minus x. The 1's go away, so we get negative x over 1 minus x. So that's 1 divided by negative x divided by 1 minus x. Reciprocal multiplication tells us that this is 1 minus x over negative x. I don't like that negative down there, so I'm going to bring it up front. And then we just have x on the bottom here. Distribute that negative, we get negative 1 plus x over x. And then if we turn this around, it'll look like this. So this is what g squared, let's call it g squared, is. So let's keep going. Let's see if we can find a pattern here. So what's g of 3 then? Well, that's g composed with g of x. Now we know what g composed with g is. We just found that. So this is really g composed of x minus 1 over x. This is what we found up here. So we just need to plug that in and see where we land. So this, again, is going to be, it's going to look ugly, but if you write it literally, you get x minus 1 over x. Do the same thing. We need to find a common denominator here. So I need to multiply the left by x over x. So we get 1 over x divided by x minus x minus 1 over x. That leaves us with x minus x plus 1 over x, because I'm distributing that negative. So this is 1 over x. Now reciprocal multiplication says that's x over 1, which is x. So g of 3, g cubed, g composed with itself 3 times, is x. Now, what's g of 4 then? Well, g of 4 of x is g composed with g composed with g composed with g of x. Now we know what this is. It's x. So this is g of x, which we know is 1 over 1 minus x, which itself is g. So this seems to be cyclic, because if I proceed from this and put g inside of g, I get back to x minus 1 divided by x. Now, if I put that into g again, I'm going to get x, and then we sort of loop. So this is cyclic. And here is a good way to represent this. So when we have n is 1, we know that we have 1 over 1 minus x. When n was 2, we have 1 minus, or x minus 1 over x. And then when n was 3, we have x. Now this is just for n 1, 2, and 3. What happens when it's 4? Well, when it's 4, we said that it's the same as g of 1. So we need to write this a little better, because we want to capture all possibilities. So n congruent to 1 mod 3 will get us what we want, because we notice that 1, 2, and 3, if I have z mod 3, I have 0, 1, and 2 are the only 3 elements. If you need a review, we've done videos on congruences, mods, all kinds of stuff. So n equals 1 is just congruent to 1 mod 3. N equals 2 is going to be 2 mod 3. And n equals 3 will just be 0 mod 3, meaning it's always divisible by 3 without a remainder. So let's rewrite this then. We have g of n of x will be equal to, let's put them in order. We'll say x when n is congruent to 0 mod 3, then x minus 1 over, nope, that's not right, 1 over when n is congruent to 1 mod 3, and x minus 1 over x when n is congruent to 2 mod 3. So this is for all n greater than or equal to 0. We will be able to represent it as one of these. So that's the closed form of g of n. G composed with itself n times, depending on what n is, will be one of these 3 functions. So we also wanted to know, what is g of 170 or 1972? Well, let's do this first. Let's look at an example. Let's say x equals 3. Just to look at what happens when we are circulating. So g of 0 of 3 is 3. G of 1 of 3 is 1 over 1 minus 3 is negative 1/2. G of 2 is, or g of 2, g squared, not of 2, of 3, is 3 minus 1 over 3, which is 2/3. What's g of 3? That's g of 0 again, right? So in other words, I could plug, in this case, we can plug g of 3 is equal to g composed with g of 3, right? So this is squared, that's 2/3. So what's g of 2/3? Well, it gives us 3. So this is cyclic in the sense that we go from 3 to negative 1/2 to negative 2/3 to 3 and all the way back. So that's what happens. Anytime we input value, we can just use one of these. We don't need to compose. So now this question of what is g composed with itself 100 or 1,972 times is just a question of what is 1972 congruent to mod 3. Again, there's many techniques you can use to do this. I'm just going to write it as a division problem, meaning I can write 1972 as 3 times something plus some remainder, and the congruence will be the remainder. So what is this? I wrote it down because I didn't memorize it. 657 plus 1. The 1972 is congruent to 1 mod 3. This is even, so it can't be 0. So our only choices are 1 and 2. And if it's 2, then I think we can divide it again. So it has to be 1. Anyway, so that means that g of 1972 of x is equal to g of 1 of x, which is equal to 1 over 1 minus x. So whatever value we want to plug in for x, if we compose it by itself 1,972 times, we will just end up at 1 over 1 minus x. So if g of 4, it's negative 1/3. All right, so that's the problem. There's one other way to think about this. I won't go into too much detail, but we can always write the Mobius transformations, it's M, as the matrix where we have 0, 1, negative 1, 1. I don't like that my matrix looks like this. Negative 1, 1. So M squared is M times M, or 0, 1, negative 1, 1 times 0, 1, negative 1, 1. Matrix multiplication, I wrote this down. It's negative 1, negative 1, 1, 0. So that's what M2 is. Now M3 is M2 times M, which is this result times M, which is negative 1, 0, 0, negative 1, which is negative I. So an identity. So in other words, negative 1 times 1, 0, 0, 1. And we can generate this. G or M of 3 gives us identity. So G of 3 will equal identity. And so we get to the same spot. So try that. That's briefly how you would look at it. But convince yourself, do M to the third and see what you get. But anyway, that's roughly what we're doing. And again, let me scroll up to the result. So here's the conclusion. And that is it. All right, so hopefully you will stick around and watch Algebra if you second, or you have stuck around and watched me. I'm second. Either way, thanks for watching. Subscribe to Algebro. He's awesome. And I will see you next time. Have a great night.
Hi guys, I'm recording this as part of a collab with a very great YouTuber named @Dogmathic. Her name Dogmathic. His user is @Dogmathic. And we are both tasked with solving this problem. So let's try to solve this. It's asking for the cyclic iteration of G. So the cyclic iteration of G, I believe, is finding G, 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 X. Okay, so, just, like, plugging this in, we have G of X is equal to 1 over 1 minus 1 over 1 minus X. So we can see it's just going to be G of X is equal to, let's call this Gi of X, because I don't know how to show the cyclic iteration, of 1 over 1 minus Gi minus 1 of X. Then Gi of X, Gi minus 1 of X is going to be 1 over 1 minus Gi minus 2 of X. Okay. So, if this goes on for infinity, this one and this one are going to be the same. So, we just say G equal to 1 over 1 minus G, we get G times, oh my gosh, times 1 minus G is equal to 1. So then we have G minus G squared minus 1 is equal to 0. So then G squared minus G plus 1 is equal to 0. G G um, blah, 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 blah. Minus 1 squared. Oh. What? There should be two things that multiply to 1 and add to negative 1. Put in 0, you get 1. Put in 1, you get 1. So maybe 0.5. A quarter minus a half plus 1. A quarter minus a half plus 1. Yeah, so this is a vertex. This looks like this. Huh. I'm gonna look up exactly what this means, because I'm not entirely sure. Sorry guys, give me a minute. Yeah, so it's like a cycle. Oh, I see. So it's like, where's my thing? It's like you're gonna have A to B to C dot 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 back to A. So how do we find that? So if we put 1 in, we get undefined. If we put 0 in, we get 1. If we put 2 in, we get negative 1. If we put negative 1 in, we get 1/2. If we put 1/2 in, we get 2. Okay. So if we put 2 in, we get negative 1. Put negative 1 in, we get 1/2. When we put 1/2 in, we get 2. Okay. Let's see, is there anything else? We put 3 in, we get 3 and we get minus 1/2. Right? Minus 1/2 and then minus 1/2 in. So 3 goes to minus 1/2, which goes to 1 over 3/2, so 2/3. 2/3 goes to 3. Oh. Okay, so I'm starting to see something. It should take 3 or 4 steps? 3 steps to get back to a number. But how do we know what number I get? Well, I mean, I clearly see here, this shifts here, this shifts here. Let's try another one. 4. 1 over 1 minus 4 is negative 1/3. Oh, we see. Okay. And then negative 1/3 would be 3/2. Just again. And then 1 minus 3/2 is wait, yeah, 1 minus 3/2 is negative 1/2. So we get 2. Wait, what? 1 over 1 minus 4 is negative 1/3. 1 over 1 plus 1/3 is 1 over 4/3. So then 1 over 1 minus, yeah, is a fourth. Okay, so our pattern is starting in n, then we go to negative 1 over n minus 1, then we go to n minus 1 over n, and we go to n. Can we show this algebraically? So if we put, oh yeah, we probably can. We have g of n, we get 1 over 1 minus n, which we see as our second one. So we start with n, this. So g of n is equal to 1 over 1 minus 1 over 1 minus n. This is going to be is equal to 1 over 1 minus n over 1 minus n minus 1 over 1 minus n. So then we just get is equal to 1 over negative n over 1 minus n, which is equal to 1 minus n over negative n, which is Okay, we're kind of there. We just don't have the negative, which we found to be true. We put 5 in there. Yeah. Or no, I guess this isn't negative. This should be negative. Because this doesn't make it negative? Because if I put 4 in here, this should be positive. But if I put 4 in here, oh, 1 minus n. I see. Because it's n minus 1 minus n. Because I made it the denominator negative. Okay, so n to 1 minus n, negative 1 minus n. Wait, what? Put 4 in here. 1 over... Oh, it is this. Negative 1 minus n is just 1 over n minus 1. Oh, I'm confusing myself. 1 over n minus 1. Negative version of that. And then n minus 1 over n. I'm going to rewrite this as negative 1 over n minus 1. So, and then this is equal to n minus 1 over n. Then put n minus, then, okay, so g of n is equal to 1 over 1 minus n minus 1 over 1 over 1 minus n. Multiply numerator and denominator by 1 minus n. We get 1 minus n over 1, which is just equal to 1 minus 1, 1, 1 minus 1 plus n, which is equal to n. So as we can see, algebraically, that's our cycle. N goes to n, g of n goes to 1 over negative 1 over n minus 1. G of n is n minus 1 over n, and g of n is n. Okay, cool. That was fun. I learned something. I wasn't really sure what I was supposed to be doing here, but I see. Cool. I wonder how Dogmathic did it. I kind of did not do the algebraic way at first. I just looked at cases and then saw from there. But, yeah. I guess, I don't know if you already saw this part of the video or if it's coming. But, cool. See you guys tomorrow. Bye. Hi guys, this is just a continuation of the video. I forgot to solve part of it. I was also asked, look at that, to find g to the 1972, wait, let me make sure it's the right date, or the right number. Yeah, it's the right number. G of 1972 of x. G to the 1972 of x. So before we determined that if we start with x, we go to x. If we have g1, we go to 1 over 1 minus x. If we have g2, we go to, so this is 1, this is 2, this is 3, or no, this is 0, 1, 2, 3, we're gonna have 1 over 1 minus, 1 over 1 minus 1 over 1 minus, wait, let me just put a number in. Number, let's put in 2. 1 over 1 minus 2, we get negative 1. So it's, or 3, I'll get, I guess. Or if we put 2 in, then we get 1 over 1 minus 3. 1 over 1 minus 3 is 1 over negative 2. So, and then put this in 1 over 1 plus 1 half, which is 1 over 3 halves, which is 3 over 2. So then we get x over 1 minus x. And then g3 of x, we get 1 over 1 minus 1 over 3 over 2 is 1 over um, negative 1/2, which is equal to 2. Yeah, I did something wrong because it should just give me x back. Oh, this is probably x minus 1. Oh, wait, let me check in the original video, see what I did, because I'm actually filming this at a much later date. Okay, after looking at what I previously did, this is what it is. So, we just need to find if it's to the 0, it's x. If it's to the 1, it's just normal. So this, we need to find mod 4, because this is a cycle of 4. So, 1972 mod 4 is equal to 0, because we know 1900, 4 divides 1900, that's divisible by 100. 72, 4 divides 72, because 4 divides 80 minus 8. So, that's 0, so it should just be equal to x, is my solution. Cool. This is probably going to be after dogmatics portion, so I thank you guys for watching. I'll see you guys tomorrow. And, yeah, have a good day, guys.